Hey there, Global Crew. We are wrapping up this year. We have two more lessons to go, and we're going to crank through both of them. So this week we'll be talking about some big kind of philosophical changes, like how people view the world. We're going to be talking today about the scientific revolution, and then your last and final lesson will be talking about this moment called the Enlightenment, which is going to be more about like politics and society and stuff like that. But we are quickly setting up what you guys will really take off with next year. So the stuff that we're going to be looking at in these next two lessons is going to be very, very important, not only to what you're going to need to do next week, because we will kind of wrap it up with a little bit of a test, online test kind of thing, but also for next year, because this is where you guys will start with 10th grade global. So today we're going to be looking at this thing that we call the scientific revolution. We're going to be throwing a couple different names out there. Two of them are going to be Copernicus and Galileo, two very famous minds in the world of science. And so we're going to be looking at how they change our understanding of the universe. Our second big question there, what impact did the scientific revolution have on European thought? I mean, just based on the name, this revolution in science, you can probably get a sense of where things are going to go. Before we jump in, though, just think about science for just a minute. Like how much science has given us in the last 500 years especially. But this idea of like discovering the universe and figuring out its secrets and then using that to develop new technologies, new medicines, all this kind of stuff. This is still relatively new. People have not been doing science for that long. And it's really because of this thing that we call the scientific revolution that we even see the world the way that we do. So that's really where we're going to get our start today. So before we jump into this, let's talk a little bit about how people saw the world before this thing that we call the scientific revolution. So we start to see some changes in how we think. Really, we've seen them throughout this whole unit. I mean, remember the Renaissance is going to bring back this love of learning. It's going to encourage people to look back at Greece and Rome and all the cool things that they did. So the Renaissance brings back this idea of education and knowing more about the world. Secondly, the age of exploration is going to give, particularly Western Europe, this desire to explore. We want to learn more. We want to see what else is out there. And then once we get into this whole Reformation, well, that's really going to break the church's hold on how people could think. So we're wanting to learn more. We're looking to explore. We're not as held back by an institution like we saw before the Reformation. So the time is just right. By the time we get into the 1600s and certainly into the 1700s, the time is perfect to really begin this thing that we call the scientific revolution. So until this point, remember, most people in Europe just accepted things the way that they were. I mean, as soon as Greece and Rome fell, remember we have this tremendous sense of like superstition and very like religious-based culture. So people very rarely questioned authority. They never questioned authority. They never stopped to say why. They just took it. Especially if it was something that the church said, because you don't want to question the church. You don't want to question God. Um, and generally, if ever there was a question about the universe, whether it's how something worked or why it existed, or why is the sky blue? Why is it that things fall when I drop them? All of this was just very simply answered because that's what God wanted. Sometimes like you ask your parents a question, and they probably don't know the answer, so they're just like, just because I said so. That's sort of the same thing that we saw, especially during the Middle Ages, because God said so. So religion answered every question, even if it was really contrary to the way that the world actually worked. And I've got a great example of how this comes into play. But before we jump into that, forgot about this. Beginning in the mid 1500s, Europe begins to undergo this pretty major change. So it's at the same time as the age of absolutism. So about the same time that all these big, powerful monarchs, Louis XIV and whatnot, are all doing their thing. There's also this big push to change things within science. So from about the 1500s to the 1700s, we have this thing that we call the scientific revolution. And it's going to be a major period of scientific change, development, new learning, new ideas. And this just is going to completely change the idea of simply accepting the ideas of the church. No longer are people just going to say, because God said so. They're going to be, I need more than that. Why? Why is it that things are the way that they are? That's what the scientific revolution is all about. So now it's time for my example. Prior to the scientific revolution, there was this overwhelming idea that existed in how people thought about the universe, known as geocentric theory. Geo meaning Earth, centric meaning at the center. So geocentric theory argued that the entire universe, including the sun, revolved around the Earth. So the Earth just kind of stood there. And by the way, remember, everybody knew the Earth was a sphere. So the Earth just was kind of there, and everything else, the stars, the other planets, the sun, they all just went around the Earth constantly. Now, why did they think this? Well, it's because from our perspective here on Earth, like it looks like the sun is traveling around us, right? Scientifically, in reality, what we know is that the Earth is the one that's moving, and it's the sun that kind of stays put, at least from our perspective. So from that, it was, people had this idea. There were some ancient Greeks who had talked about it. There's actually also some Bible verses. In fact, in the book of Psalms, it talks about how the earth is fixed and does not move in its foundations, which kind of, says exactly that. The earth doesn't move, everything else goes around it. But then in the mid 1500s, we began to see some people who began to challenge this idea. I mean, unfortunately, the guy that you can't really see, he's right up here, that's Nicholas Copernicus. He began to kind of argue differently. So he began to do a bunch of evidence. He began to take some measurements, study the stars, the movements of the planets, all that kind of stuff. And he really began to argue for this second idea that we call heliocentric theory. Helio meaning sun, centric again meaning at the center. So heliocentric theory says, we have it backwards. It's really the sun that's in the center of our star system, and everything else, including the Earth and all the other planets, go around the sun. Now, later, there was a guy named Johannes Kepler. Johannes Kepler, who has that fantastic collar in that photo and a sweet mustache. Anyway, it was Johannes Kepler who continued to do a lot of work into this. He continued to do more measurements, and he pretty much said, oh, yeah, Copernicus knows what he's talking about. It's in fact true that the sun is at the center of our star system and everything else moves around the sun. Now, of course, how do you think the church thought about this? Honestly, at first they didn't really care because nobody was really listening to these guys anyway. So for the most part, the church, even though they would argue that people like Copernicus and Kepler were speaking out against things that they thought were real, the church didn't really pay them too much attention. And then you get this guy. Then you get Galileo. So all of these ideas, Copernicus and Kepler, their ideas were given way more credit by a guy named Galileo Galilei. How do you like that name, by the way? Galileo Galilei. So Galileo Galilei was this Italian astronomer. He actually built one of history's first telescopes, which you can see at the bottom of the screen there. And one of the things that he did is he wanted to verify, is Copernicus correct? So he took more measurements, he looked at more stuff, he plotted orbits around the sun, all this kind of stuff. And he pretty much said, nope, you know what? The ancient Greeks, the things we've been telling each other for a while, even the Bible itself, has some inaccuracies in terms of how the solar system is set up. So instantly, this is going to cause some problems. And unlike the other two, Galileo's ideas were much more highly publicized. It has a lot to do with when he lived and who listened to him and things like that. So Galileo was actually arrested by the Catholic Inquisition and he was tried. He was put on trial in 1633, where he was pretty much threatened with death unless he stated publicly that he had been wrong. Oh my gosh, my ideas are terrible. I'm such a horrible person, which actually he did. They threatened him to the point where he kind of had to give in, which was sort of sad. But he knew he was right. They only put him under house arrest for the rest of his life, which means he just lived in his house all the time and he couldn't leave, which is how I'm sure some of you are feeling right now. But anyway, so Galileo was put under house arrest, and he continued to do more scientific work. He continued to write things. And what he kind of begins to do is sort of open that door just a little bit to the point where, like, science might not always agree with what the church is going to say. And when that happens, when there's a dispute between science and the church, well, who do we pick? How do we know what's real? So there are a number of people, a number of actually pretty prominent scientists that often refer to Galileo as I have up on the little box out there, the father of modern science. So if you guys are familiar with like Neil deGrasse Tyson, if you're familiar with Stephen Hawking, like these men of incredible scientific knowledge today actually refer to Galileo as the father of modern science. And he kind of earns it because he's, again, challenging the church. He's challenging these ideas and trying to show what's real and true despite what tradition has said. There's another very important person, though, who's definitely one of the fathers of modern science, and that's this guy who has amazing hair. Not a wig, just beautiful hair. Anyway, his name is Sir Isaac Newton. Sir Isaac Newton is an English scholar who studied a lot of different aspects of the universe. He was most famous for his mathematics, actually. He wrote a whole big book called Principia Mathematica, where he just talked about how amazing math was. But he was most famous, at least most people remember him, for demonstrating how gravity works. So he didn't invent gravity. It's always been here. But he was one of the first to really play with the idea of how gravity actually functions. So, if I pick up my Roku thing here and I drop it, we know that it's going to fall because of gravity. And he really wanted to know why. So a lot of our ideas of gravity and how gravity functions come, at least at first, from people like Sir Isaac Newton. So he's using a lot of math to prove this kind of stuff, but ultimately he did a lot with light as well. And you've probably heard of the story where he's sitting under the apple tree and an apple falls on his head, and he's like, "Oh, I wonder why that worked." Anyway, does a lot with gravity, a lot with math, a lot with light. And he began to notice as he's doing all of this research that the universe itself seems to follow certain laws. It's almost as if there's like certain laws that the universe has to obey, or else it's just not the norm. I mean, if I drop this, we know without a doubt it's going to fall. Caught it. It's going to fall because that's a law. It's the law of gravity. So he begins to notice these laws. Well, there's a funny thing about laws. At least at that time, there's this general idea that if you have a law, well, you must also have a law writer. Before we get into that, though, let me define this. So Newton began to argue that the universe followed these things called natural laws. They're specific rules that the universe operated on. Gravity, entropy, so like energy leaves a system over a long time with thermodynamics and all that kind of stuff. And essentially these laws, these things that the universe runs on, could be discovered. We can figure them out. If we study enough stuff, we can figure out what the little tricks of the trade are, what all the little rules are to this game that we call life, and we can study them, and then we can use them to predict how nature occurs. So if you think of something like meteorology, the study of weather, weather is all about understanding, meteorology rather, is all about understanding how the weather works, noticing what's going on right now, and then trying to figure out what happens next, right? And that's the kind of stuff that people like Sir Isaac Newton are looking at. Now, some people, not Newton, because Newton himself was actually a very devout Christian his entire life, but some people after Newton began to kind of take this idea of natural law and they began to play with it a little bit. So one of the things that we see is yes, there's this big backlash against traditional religion, and at the same time, there's also this idea, there's these laws that are there. Well, who wrote these laws? So there's actually a whole new type of religion that shows up during this time called deism. And deism became pretty popular during the late scientific revolution, but also afterward. And it kind of began to argue that once upon a time, there was a creator God in the universe. He created the entire universe. He wrote all the laws and set them into motion. And then he just left. He just left. So deists believe that there used to be a God and he's not here anymore. Now, why did they argue that? Because they figured, they didn't have a good explanation for how things got the way that they were. We didn't have evolutionary theory yet. There was no Darwinism. And yet it helps to explain things, at least in their mind, and why certain principles exist. So what's interesting about deism in particular is deism was actually super popular in the young United States. In fact, many of the founders of the U.S. Were actually deist. They weren't Christian. Christian, especially people like Thomas Jefferson. Thomas Jefferson was very much a deist. So these ideas, this scientific revolution thing, is going to be super important even into the history of our own country. But one of the biggest pieces of the scientific revolution is really the beginnings of this thing that we call the scientific method. So during this time, we have a particular English scientist by the name of Sir Francis Bacon, the most delicious name in history, I think. But we call him Sir Francis Bacon. That's his name. So he creates this like step-by-step process of scientific discovery. And I'm sure you've seen it a million times. It's right up there. You know, essentially you state the purpose, you do some research, you form a hypothesis, you experiment, you analyze, you conclude, and then the thing that's not up on this chart, you repeat, because science is constantly having to prove itself. You have to keep proving the truth. And if it's no longer true, then you need to figure out what that new true really is. So again, you can't base truth on belief, so says science. It needs strong evidence. And most of us in the modern world, we get that. Like we don't, well, some of us do, but we shouldn't just accept things as the way they, just why is this the way that it is? We want to know, like, give us evidence, show us stuff. Don't just say, because God said so, or because the government said so, or we want to know why. Now, once we have the scientific method, once it's in place, it's going to lead to all sorts of major advances. Into the 1600s, we start to see scientists exploring the circulatory system, understanding how the heart and blood work. We start to see the first microscope. Once we have the first microscope, we can discover the first cell. So this is going to be huge in terms of like microbiology, understanding everything from bacteria and germs to a million other different things. By the 1700s, we start to see the development of modern chemistry, which will give us so much. And you guys have no idea how important chemistry is to the modern world. I mean, chemistry is the paint that you see. It's the ink that's in your paper. It's the plastics that you use all the time. And this is chemistry. We are surrounded with chemistry. It's also the first time in the 1700s that we have a smallpox vaccine in Europe. So we start to see a lot of these vaccines to try and help people and improve health. So all of this stuff begins to kind of pile together and really begins to prove to Europeans especially that there's a value in this idea of reason and understanding the evidence and the process behind something instead of just blindly accepting it. So what happens as a result? So once the scientific revolution is really in play, where do we go? Well, it kind of begins to raise a very important question. If the church could be wrong about an issue like geocentric theory or anything else, what else could it be wrong about? So people are really starting to think differently. It's going to lead to a questioning of the church. It's going to lead to a questioning of the way that the world works, not just scientifically, but also, politically, socially, all that kind of stuff. People are just not going to want to accept the norm anymore. They're going to want to know, like, why is it this way? Let's make it better. Plus, we're going to see all sorts of different major discoveries in medicine and science, all this kind of stuff. Certainly if you're improving medicine, you're going to let people live longer. You're going to let people live healthier lives. And then lastly, it's also going to lead to a big push towards reason over faith. So again, it's not that everybody in Europe is instantly going to become an atheist, although now we're starting to push in that direction. It's just that we can't be held hostage by superstition anymore. I mean, you need to have this sense of reason and logic and evidence to really make things do what they'll ultimately do. So again, we're pushing Europe towards something that's more modern. We're pushing towards a modern world that's really going to be important to you guys in understanding world history next year. So with that, I'm going to close this out. Only 2 more weeks of classes this week and next week. So if you guys have any questions, if you're behind in back work, now's the time to get that done. The finish line is coming up. I know some of you are just really not enjoying these online classes, but we'll get there. We'll make it through. Have an awesome rest of your day, and we'll talk to you guys later.